All right, daily tip, take 2 from yesterday about the stoichiometry lab. Want to start with a couple of questions that are in your conclusion, except I'm using different numbers. So there's a question about if you take 8 grams of the hydrate, how many grams of the anhydrate do you have? So I want to make sure that you understand that this little dot right here, that is not a multiplication sign. That means you have something called a hydrate, which means that there's some waters clinging to the ionic compound because of electrostatic attractions. So in this particular hydrate, calcium chloride nonahydrate, this one calcium chloride has 9 waters clinging to it, and they're pretty easy to get rid of. All you have to do is just heat up the hydrate. So your question has different numbers, but I'm going to use 8 grams of calcium chloride nonahydrate. This is the formula for that hydrate. So we want to find out how many grams of calcium chloride are in there. Okay, so from the periodic table, we count up the mass of 1 calcium, 2 chlorides, 18 hydrogens, and 9 oxygens, or 9 waters. And that comes out to 273 grams. Then we want to get the mass of just the calcium chloride without the water. And when we say without water, we have a prefix for that. Without is anhydrate. In other words, without the water. And that would just be the mass of the calcium and the 2 chlorides, which is 111 grams. And when you do the math, you should come up with 3.25 grams. So you could heat that up, measure it before, measure it after, and you could figure out how much you should have. Let's do the second example. Here's the magnesium sulfate heptahydrate. 7 waters for every 1 magnesium sulfate. So 8 grams of the heptahydrate. So you need grams down here of the heptahydrate, which is, I think it's, let me do a quick calculation here. The magnesium sulfate is 64. That's not right. $24.3 plus 32 plus 64. That's 120 grams. Let me get rid of that. 120 grams, and then we add in the 7 waters, and that is 246, and you can do the math there. All right, now you've got another question that is asking you about if you are given, I think it's 1.5 grams of calcium chloride, and maybe it's something different, I don't know. But from 1.50 grams of calcium chloride, how many sodium carbonate do you need to exactly react? Well, they don't react on a gram-to-gram basis. They react on a mole-to-mole basis. So first we have to figure out if we have 1.50 grams of calcium chloride, how many moles is that? So our conversion factor is going to be grams, so that grams cancel, and we want moles up here. Well, we only need to know how much 1 mole is. So 1 mole of calcium chloride is 111 grams. So 1.5 divided by 111 is that's not right. Maybe that's right. Okay. Is 1.0 1.35 moles. Let's do that again. 40 plus 71 divided by 1.5. Okay. Now, since these react on a 1-to-1 mole basis, that means you must have 1.35 moles of sodium carbonate. Well, you can't measure out moles. You have to figure out how many grams that is. And we need to find out grams. So our conversion factor is going to be kind of upside down of that last one, because we want to get moles on the bottom because we want it to cancel out. So 23, 23, 12, and 48 is 106 grams for every 1 mole of sodium carbonate. So we would need 1.43 grams. Now what that means is that if you take 1.43 grams of the sodium carbonate and 1.50 of the calcium chloride, they will completely react to form as much of the product as possible. I did make a mistake right there. That's not 111. That should be 273. Sorry about that. And I think all of your calculations will be a little bit different. So I'm so sorry I got that wrong, but you'll need a 273 there. Because that's the formula of the hydrate. So when you come over here to moles, you'll have a different number here, but you can figure that out. All right, I'm going to make some more videos to send out for the test, and I hope that helps.